It was a fruitful discussion. I believe the convergence of artificial intelligence with finance will enable us to progress further on banking services. The next session is more on a technical note. The title is Machine Learning Best Practices. The panel takes up on this technology by elaborating on the primary use cases. And the panelists will be Ahmet Onur Durahim from Bogazici University and Princip AI, and Fuat Beşer and Global AI Hub.
Hi everybody, and welcome to the Machine Learning Best Practices panel. First of all, I hope you're all safe and healthy. So I'm Ahmet Onur Durahim. I'm going to be the moderator of this panel. I'm a professor in the Department of Management Information Systems at Bogazici University, doing research and giving lectures in data analytics, graph analytics, natural language processing, and machine learning. I'm also the founder of Princip AI, an AI company which is specialized in developing systems that does sequential decision making, such as algorithmic trading agents, and also specialized in NLP, natural language processing. So in Princip AI, we are developing products using state-of-the-art machine learning and NLP algorithms. Let me introduce to you our panelist, Fuat Beşer. Fuat is the co-founder and co-CEO of two Swiss-based AI-related companies. First one is the AI Business School, which creates high-quality online AI courses for everyone, technical, non-technical. And the other one is Global AI Hub, where AI talent meets opportunities. Fuat is also participating in voluntary AI community activities. He founded Turkey's leading AI community named Deep Learning Turkey. He is recognized by Google as Google Developer Expert on Machine Learning, by Coursera as a Turkish language coordinator, and by deeplearning.ai as AI ambassador. I want to welcome Fuat. So, welcome to the Istanbul Fintech Week's Machine Learning Best Practices session. So, today in this panel, we are going to discuss what machine learning is and what are the best practices. So we have learned from the previous panel the importance of AI and impact of it in financial services. Now we are greatly motivated to learn about machine learning in general and the applications of and best practices in machine learning, specifically used in financial services. So let me give you a brief overview of what we are going to talk in this panel. So we are going to talk about AI literacy and what should business executives, non-technical people, need to know about machine learning and AI, artificial intelligence in general. Then talk about specific applications of machine learning in financial services and the steps taken in machine learning projects. Since in machine learning projects, it's not just choosing a machine learning algorithm, just choosing it and applying it. Although people are working on automating these machine learning projects, it is actually a process. So we will discuss on it on giving use cases. So we will talk about machine learning that is used in loan approvals, algorithmic trading, which actually uses historical as well as current data, and how machine learning may be utilized in financial news aggregators, which analyzes huge amounts of information created on the internet and over the social networking sites, also known as big data. So we will talk about how do we detect fraud, assess risk, and how do we carry out credit scoring using machine learning techniques. So we will also talk about chatbots, but leave the details to the next panel. And last but not least, we will talk about the legal aspects of machine learning algorithms, since in machine learning algorithms, we sometimes collect and analyze personal information, which is really important in the domain of financial services. So we are going to talk about these machine learning techniques and elaborate on the best practices and primary use cases. So let me start by asking Fuat, Beşer, so what is machine learning in general? Could you please explain us what machine learning is and what are the different types of machine learning that are used today?
Thank you so much for the nice introduction, and also wholeheartedly thank the Istanbul Fintech Week organization team to inviting me to this wonderful event. AI is once again a hot topic in the world of tech and beyond. AI and at this moment, AI and machine learning all around us, and I believe AI and specifically machine learning are changing our world's economy, companies, and our society with increasing speeds. Because actually there are different underlying technology groups like machine learning, deep learning, robotic process automation, speech and speech recognition, computer vision, and others. So if we look at the relevance of AI even today and compare with what people actually know about it, we come to the conclusion that most people, unfortunately, don't know anything about it. Even business leaders, and as a AI business school, we want to change that. Machine learning emerged as a branch of AI that allows us utilizing the power of intelligence for deeper and contextualized purposes. A few years back, the fintech companies and the other companies also were forced to do everything with the help of human analysts, human model builders, and the other highly skilled and experienced staff. Today, machine learning is capable of assisting analysis of the market patterns, taken into account previous cases, and building a successful analytical model with little to no or a little intervention from humans. The scientific field of machine learning is a branch of artificial intelligence as defined by I would like to use the definition from the computer scientist and machine learning pioneer, Tom Mitchell. He defines machine learning as a study of computer algorithms to allow computers program to automatically improve through experience. In a nutshell, machine learning is a subset of artificial intelligence involved with the creation of algorithm which can modify itself without human intervention to produce desired outputs by feeding itself through the structured data. For example, in the financial services, this desired inputs maybe we have some transaction data, and we want to classify this transaction data into two basic class, fraud or genuine or non-fraud class. So another crucial subset of AI and machine learning is the deep learning nowadays. Where algorithms are created and function similar to those in the machine learning, but there are numerous layers to these algorithms, each providing a different interpretation to data it feeds on. Deep learning networks, network of algorithms are called artificial neural networks, being named so after their functioning and inspiration, or you may say attempt to imitating the functions of the human neural networks presents the human brain. Yeah.
Thank you. So could you please elaborate on the differences between what we know as supervised and unsupervised learning, which these techniques are used a lot in financial services also. So could you please elaborate on it a little bit?
Yeah, thank you. We may say that an algorithm basically can be taught as a set of rules or instructions that computer program specifies, which computer can process. Simply put, machine learning algorithms learn by experiences, similar to how we do as humans. For example, after having multiple examples of objects or some transaction data, a computer employing machine learning algorithms can become able to recognize the object in new, previous, unseen scenarios. Machine learning basically consists of applying mathematical and statistical approach to get machines to learn from data. We say learn from, as we human, we are learning by experience. It consists of three main techniques: supervised learning and also the unsupervised learning and reinforcement learning. If we want to define and describe supervised learning is a technique consists of providing labeled data to machine learning model. The labeled data set is usually data gathered from experience, also called empirical data. In addition to data often requires preparation to increase its quality. Some data cleaning processes before feeding the data into machine learning models, fill its gaps or simply optimize it for training. But when it comes to unsupervised learning, in contrast to supervised learning, unsupervised learning consists of working with the unlabeled data. In fact, the labels, when we are saying the labels, for example, when we are trying to detect the fraud, you have basically transaction data from the customer, and we are labeling these lines, for example, these lines, fraud or non-fraud, we are labeling this data. So unsupervised learning consists of unlabeled data. In fact, in these use cases are often difficult to obtain these labels. There is not enough knowledge of data, or labeling is too sometimes too expensive. Moreover, lack of labels make it so hard and so difficult to set goals for trained machine learning models. It's therefore complicated to measure whether the results are accurate or not. Even though that is the case, multiple techniques allow obtaining results that lead to obtaining a better grip on the data.
So, thank you. So, we know that today we are talking about these deep learning techniques, which actually boost the performances of these machine learning models, actually. So deep learning is a subset of machine learning. So actually, what do we need to create a good machine learning model? So as we know that deep learning today, actually the main ingredients to the deep learning techniques are the huge data sets. Actually, we have huge unlabeled data sets, and what we need is in deep learning, generally we need supervised learning data, which means labeled data. As you mentioned, it is really expensive and costly to create these data sets. In addition to this, deep learning architectures are huge models, which requires huge computing capabilities and designing new architectures. So thinking about these new architectures, the requirement about the big data and the huge computing resources, what can you tell about what should the business executives, the non-technical people, need to know about machine learning?
They should, first of all, they should know all the aspects of machine learning. If you want to create the basic machine learning models, you need data, lots of data, or some of the problems require a lot of labeled data to succeed in these topics. Another crucial part of the machine learning algorithms also the algorithm part. You need state-of-art algorithms and you need to feed data into these algorithms. And also the third one is you need also the high computing power to analyze this data, and also the fourth one is the AI talents. I would like to emphasize this this part. Yes, you don't have any enough data, but you could do some feature engineering and some smart strategy to get insights from data without having a lot of data or a lot of computing power. I think they should get some AI talents and also some insights from the data.
Yeah, you mentioned about this feature engineering, which is an important step in machine learning projects. And actually, as we know, deep learning tries to avoid these, actually to replace this feature engineering part. Could you please elaborate on what feature engineering is and why it is important in machine learning projects?
There are two, I think there are one main difference between the deep learning and machine learning. When you have a lot of data and also a lot of computing power, you should need to use deep learning techniques and also, but if you don't have enough data or enough computing power, you should do some feature engineering. If you want to define describe the feature engineering, as we human want to describe or classify the fraud or non-frauds. We are taking some clues from the data. Yes, this can be fraud or this can be non-fraud. We should take notes from the human experience, and we want to and we should apply these techniques to computers. Yeah.
So actually in feature engineering, we are trying to come up with, I think, the features that may help us in solving these machine learning tasks. So let's assume that we have a problem, we want to compute the credit score for a loan applicant. So what we need to do is which features of that applicant we have to look at in order to reach to a conclusion whether we should permit this loan or we shouldn't do that. So what can be these features, like what is the income of this person and what is the age of this person? So this study of extracting these features that may help us in solving these kind of projects is really an important step, and it takes a lot of time, and it is again costly. So as you mentioned, in deep learning, we're trying to reduce the costs of this feature engineering and try to work on raw data. And what do we mean by raw data? Let me give you an example in face recognition task. So in face recognition, actually what is the input to the model is the pixels of the photograph taken from, let's say, our smartphones. So if you're trying to, in machine learning part, what we do is we're trying to come up with the features, whether we have these curvatures and whether we find the mouth and etc. But in deep learning, we just feed just the pixels of this photograph to the model, and it directly learns these important features, the edges and these curvatures and etc. by itself. So by using these deep learning techniques, we actually skip this timely and costly feature engineering part. So Fuat, could you please give us some use cases? I know that you have accomplished lots of machine learning projects. Could you please give us some use cases and which machine learning algorithms have you used in those projects?
Thank you so much. I would like to emphasize three the important use cases, machine learning use cases for the financial services. The first, the fraud detection, risk management, and the chatbots. The last one is the chatbots. At first, we should learn and know the machine learning pipeline for example, the fraud detection part. At first, we are gathering some data, and we are feeding this data into the machine learning models. The accuracy of the machine learning models depends on the amount of data on which it's trained, and the more data, better the model performs. For detecting frauds specific to particular business, you need to input more and more amounts of data into your model. This will train your model in such a way that it detects fraud activities specific to your business perfectly. For many real-world data sets where we would like to perform classification using the data as it simply won't cut it. The reason that most classification algorithms, such as a logistic regression from the machine learning, one of the machine learning algorithms, assume that the number of observations from each class, for example, fraud or non-fraud class, are roughly the same. But when the data is heavily imbalanced, the algorithms will start to predictions in favor of the majority class, for example, non-fraud class. Unfortunately, the minority class tends to be one of the one that we are interested in identifying. For example, the fraud class, as it's the case with the people with a rare disease or detecting the class. The second part is the extracting the feature extraction, as we talk, basically works on the extracting the information of each and every thread associated with the transaction process. This can be the location from where the transaction is made, or the identity information of the customers, or the mode of the payments and the network. For example, when we are talking about the identity of the customers, the customers' emails, address, mobile number, and also the credit score of the customers, or the location parts. We should, when we are trying to detect the fraud, we should also check the location or IP address or the other shipping address, and also payments behavior, mode of payments, and also, for example, if he or she is paying always and using one card, and he changed this behavior, he or she changed these behaviors, we can somehow detect the payment fraud, and also the next stage is the training the algorithm. Once we have created a fraud detection machine learning algorithm, we need to train it by providing customers data so that the fraud detection algorithms learn how to distinguish, how to classify to these fraud or non-fraud transactions. And also the next step is the creating the machine learning models. Once we have trained the fraud detection algorithms on specific customer data sets, we are ready with the model that works detecting fraudulent or non-fraudulent transaction in our business. For example, MasterCard integrated the machine learning and AI to track process such variables as transaction sites, location, time, device, and purchase data. The system assess account behavior in each operations and account behavior provides a real-time judgment on whether a transaction is fraudulent or non-fraudulent. And also Feeds AI, a fintech company from Portugal, claims that the fine-tuned machine learning solution can detect up to 90% of the fraud or minimize the cost of manual detection surveillance accounts for new 25% of the expenditures. With more technological innovations, there are more risk of fraudulent transactions nowadays because people and also the banks and digital companies are creating more and more digital data, and for also this is true for the financial organizations. The financial services industry is suffering from the fraud related losses more than any other industry nowadays. The financial industry takes two approaches to main approach: the rule-based system, the traditional one. The second one is the machine learning based approach.
What are the main machine learning techniques used in detecting these fraud? Could you please give us some best practices or examples of these techniques?
Supervised learning, as we talked before, supervised learning approach is commonly used for fraud detection. To use this approach, this supervised learning, machine learning approach, we must have quality data. When we are saying the data must contain the features on which the final output depends. As we talk, when we are trying to classify or distinguish between the fraud or non-fraud transactions, we need some identity data, as we talk, or some address, some IP address, for example, and also in fraud detection, it can be name of vendors, details of transaction data like date and time and location, bank name, source name, so and forth. Outputs or labels is true or false to value to indicate fraud or non-fraud transaction. Sample data is used for training machine learning models. After the training model can be used for future prediction, detecting and a classification task, basically. We can use classification model. There are plenty of machine learning models for classification tasks. Some of them which promising, giving some promising results like logistic regression, some traditional support vector machines, and also when we are talking to deep learning and neural network and some naive-Bayes.
Okay. So you mentioned about these supervised learning techniques. So actually NLP is natural language processing is used in some financial services applications. So let me give you some example about these applications. So actually the problem with these supervised learning techniques is the shortage of this training data. But we know that over the internet, we have huge amounts of natural language texts. So how can we utilize these texts is through these transfer learning. So what do we do in transfer learning? We try to learn something useful from a natural language task, such as language modeling. Actually, what is a language model? What we do is, okay, for the given sequence of words, what will be the next word? How can we predict this next word? So why this is important, why language models are important. So today, the state-of-the-art machine learning models are in NLP are using these transformer architectures together with this with this transfer learning approach. What we do is, okay, we have lots of sentences. So we need, in supervised learning, we need labels. So actually, there is a new technique called self-supervised learning, which means instead of human labeling, we want automatically label these texts. So language model fits this in this approach. Why? Because we want to predict the next word. So let's assume that we have, okay, we are using today advanced proposals of convolutional neural. What should be the next word? Okay, so there are several articles written on these topics, and we know that when you say convolutional neural, then the next word to be predicted will be most probably a network. Okay, so using this task, we learn some AI model. So we use this model to predict this next word, or there are some approaches known as masked language models. So for a given sentence, we mask randomly a word, and we want our model to learn predicting that masked word. Okay, so these models can be trained using unlabeled data, just the big, huge amounts of textual data. Okay, but how can we use it for creating chatbots? Or we want to perform stock price predictions using news articles. So we want to, one of the approaches that we are also using in our company, Principe AI, is extract the sentiment of these news. So how can we use these pre-trained models which utilizes this transformer architecture, which is again today the state-of-the-art machine learning technique architecture here. It uses actually attention mechanism. So what are the well-known deep learning architectures using artificial neural networks are convolutional neural networks and recurrent neural networks. Actually, convolutional neural networks are used to learn local information, and we use recurrent neural networks, especially LSTMs are used a lot to learn sequential relationships between the data sets. But we need to spend a lot of time training these models, and in recent articles, our audience may check Attention is All You Need, entitled article, which proposes a new architecture called attention mechanism. And this leads us to train these models on GPUs, graphical processing units, and they are much more parallelizable as compared to these LSTM models in NLP applications. Okay, so what was our problem? We want to come up with the sentiment analysis, actually sentiment of a given sentence. So what we do is we first use a pre-trained language model to get the representations of the words within this sentence. Okay, so actually the important word here is contextual word representation. Then fine-tune this model, putting an additional layer. The technical people will know what an additional layer is, to fine-tune this model with less amount of labeled data. So again, we need to have some labeled data set. What do we mean by labeled data set? So we have some sentences, and we know the exact sentiment, whether it carries a positive sentiment or negative sentiment, or it's a neuter sentence. And let's assume that we have a small amount of these supervised labeled data set, and we use this to fine-tune these language models to create a model to predict sentiment analysis, to do sentiment analysis. Actually, this architecture are also used to create chatbots and question answering systems. So these are important in developing products like robo-advisors that we are currently doing that one. So another example for the supervised learning, you mentioned these loan applications. So what do we want to do is, whether you have a financial fintech company that provides loans to, let's say, in the domain of agriculture. So how can we predict whether we should approve a loan or not for an applicant? So actually, the techniques used for object recognition and these actually image recognition are used to predict whether what will be the harvest in specific areas of countries using these satellite images. So actually, in addition to what you mentioned about specific features about the applicant itself, we may also use machine learning to predict the amount of harvesting in the next month or year. So actually, as you mentioned, there are techniques used as machine learning techniques, the logistic regression, the decision trees, and etc. And one of the most widely used techniques nowadays is an ensemble methods. So instead of using just the decision trees or the logistic regression, just use a combination of them. So our audience may check gradient boosting trees, cat boost, and other light GBM. These are the proposals made by big companies like Facebook and OpenAI. So let me mention one more thing. When I was talking about pre-trained models, nowadays we are talking about a lot about this GPT-3, which is also a pre-trained language model. So you mentioned you will talk about these chatbots and risk managements. What can you say in, actually we have, I think 2 minutes left.
For the risk management is another field where machine learning can do great things by knowing the information from not just inside of the company, but also from outside customers. And machine learning can help in better risk management and prevention of the future losses. Risk management is the crucial success financial health of the banks and other institutions. Machine learning is the key element for the risk management, allowing to evaluate all the factors to make a well-grounded decision. For the chatbots, more than ever, financial institutions need to decrease labor cost or improve customer satisfaction rates, but the need for the better and safer and customized solution is rising with expectation of the customers. Although the number of the customers are increasing day by day, how can this can be goal achieved without any exponential investment? The answer is crystal clear for me. By using technology like chatbots or machine learning techniques, helps financial institutions to solve customers' issues immediately. In Turkey, lots of banks are introduced their chatbots to provide customers with instant information about balances, transactions, daily customer issues and conversations, and also the customer rating and other related methods. Chatbots are beneficial in banking and financial institutions because they save the money, increasing customer engagement and streamline customer support. If you want to create the chatbots, and you need machine learning and also the data.
Okay, so last topic I want to mention is, okay, we are using these machine learning techniques in loan approval and detecting the sentiment of these news and etc. But there is a criticism known as black box criticism. So can you talk about this explainable AI? Because this machine learning, we are using these machine learning techniques to help us deciding on whether approving or disapproving the loan applications. But actually the GDPR and GDPR actually requires us to be, our decisions to be explainable. So how did we come up with this decision? So could you please lastly elaborate on this explainable AI?
Thank you. The processes behind how modern AI, or specifically when we are saying the machine learning works, is not always obvious. Many of today's advanced machine learning algorithms that power AI systems are inspired by the process of the human brain, neural networks, but are limited by their lack of human ability to explain their actions. Mm-hmm. Yes, machine learning models are good at classifying frauds or predicting the next word, but they have a lack of the ability to explain their actions or reasoning. With this in mind, nowadays entire research field is now working on towards describing the rationale behind the AI decision making. We are calling this research area as a explainable AI. While modern systems demonstrate performance and capabilities far beyond previous technologies, practically and legal compliance presents hurdles to successful implementation. For organizations are looking to utilize AI and machine learning effectively, explainable AI be the key deciding factor due to its ability to help foster innovation, enable compliance with regulations, and also the optimize machine learning model performance and enhance competitive advantage. Most current AI practice focuses on the performance and with explainability deal with as an afterthought. However, both the AI community and industry are coming to see the need for more transparent AI systems, specifically for the financial services, as a solution are evolving at past contained proof of concept to deployment at scale. They recognize the importance of explainable AI. Assigning or denying credit is consequential decision that is well regulated to ensure the fairness. Many opportunities for applications in credit risk scoring are dependent on the ability of the AI application to provide a robust explanation of its recommendation or prediction. Beyond compliance, we should the value of explainable AI can be seen for both clients and also the banks, financial institutions, because clients can receive clear explanation that give them the information they need to improve their credit risk score or credit profile, while the service providers, financial institutions, can better understand predicted clients churn or adapt their services. Explainable AI in, for example, in credit risk scoring can also help with de-risking. For instance, explainable AI model might provide an explanation of why model pool of assets has the best distribution to minimize the risk of the covered bond.
So actually, we want to prevent the discrimination and the gender biases and racism that may output from our machine learning models. Why? Because since we are training these models with human-generated data sets. So thank you, Fuat. Thank you for sharing your expertise with us. So thank you for all the audience for watching us, and I want to also thank to the organizers of this Istanbul Fintech Week. Thank you very much.
Thank you so much.